All right, here's our last video of the chapter. So we're going to finish the idea of related rates, and we're going to finish with doing a couple questions that are two formula related rates instead of one formula related rates. So everything to this point, we have either had a formula for area or volume or the Pythagorean theorem. Those are kind of the most prevalent. But now we're going to look at a couple that require a couple different formulas and involve kind of a few extra steps. Still the same idea of looking at things that are changing, things that are related, all with respect to time. So for this first one, we have a balloon that's being filled with helium at a rate of 4 cubic feet per minute. That is a volume change. So the first thing you should notice here is because it's telling you how the volume is changing, cubic is a big key there, seeing a cubic unit. That's your dV dt. And it wants to know the rate at which the surface area is changing. So I'm going to call the surface area S. So what this question is asking for ds dt. And they specifically want to know at the moment where the volume is this value. So when you're doing a question like this, they will give you formulas that you need. So you're looking at the screen right now and probably thinking, I need some more formulas to be able to do this. They will give you volume of a sphere formula, which is 4/3 pi r cubed. They will also give you surface area. They do not, no one on the AP test or myself expects you to memorize the surface area of a sphere, not something you use very often. That formula is 4 pi r squared. So you'll notice in Delta Math on my test, on an AP test, it will actually say in the problem using this formula, so you're not memorizing it. So first, I want to start off by deriving my volume formula. Everything is changing. You'll notice that my volume is changing, my radius is changing, my surface area is changing. So everything needs a variable. So when I take dV dt, I'm going to do a power rule, power out front. It's going to cancel with a 3 in the bottom, power 1 less. And then the derivative of r is dr dt. Now they give us some information. I'm going to come over here so I have a little more room to work. Excuse me. They tell you that the dV dt is 4. That what they don't tell you is what r is. But they give you this piece of information, which is enough to find r. If you set your volume formula equal to 32 pi over 3, so set that equal to your volume formula. This is kind of a roundabout way of giving you the r value because they didn't directly state it, but they gave you enough information to find it. The pi's cancel, the 3's cancel. You can divide both sides by 4, so you get 8 equals r cubed. And so that means that r must be 2. So it took a little work. It would have been nice if they would have just come out and said the radius was 2, but now we have it. So we're going to put a 2 in here. And then finally, we're going to divide both sides by this whole thing, which is ended up being 16 pi. I am not going to take the time to get a decimal for that. I might reduce it. I might write it as 1 over 4 pi. But grabbing a calculator and getting a decimal is not necessary right now. So here's why we did that. That's not what we want. We actually don't want the radius is changing, but I'm going to need that to answer the second part of the question. And this is why it's a 2 formula question, because we did a whole bunch of stuff with this volume formula, but it was just to get us to be able to use our surface area formula. So the derivative of surface area, ds dt, is going to equal, again, a power rule, power out front, power 1 less. Now I'm going to plug in everything I know. I know now that my radius is 2. I found that earlier. I also know dr dt is 1 over 4 pi. So I get 8 times pi times 2 times 1 over 4 pi. We're actually getting a pretty simple answer here. My pi's are going to cancel. I'm going to end up with 8 times 2 divided by 4. So 16 divided by 4 is 4. And my unit, since it's surface area, is going to be feet squared per minute. Oh, I started writing second, sorry, per minute. So that is how you do a question that has multiple variables. So again, you're kind of noticing a lot of things going on here with these. All right, so let's do one more. So this next one I took from I took this one from a Delta Math question because I wanted you to see kind of how they're going to ask questions. It's also, I took it from the section that was called Related Rates to Formulas. So this one is dealing with a circle. The circle, we know about the area and how it's changing. The area is decreasing at a rate of 409 square meters per second. So I'm going to make a little comment over here. That means dA dt is negative 409. I like to kind of read the question and write down each piece of like, what is it telling me? It wants to know at the time when the radius is 9, what is the rate of change of the circumference? So I'm going to call the rate of change circumference dc dt. And it is telling me that we could get decimal answers, and I do like that Delta Math sticks to that 3 decimal place rule. They will probably not give you formulas for area. Volume formulas tend to be given, area not. So my area of a circle is pi r squared. And circumference, that's the other formula I'm going to need, of a circle is 2 pi r. I'm going to derive each of them because everything's changing. Area is changing, circumference changing, radius changing. So I'm going to derive this one. I'm going to get dA dt equals power out front, power 1 less, put a dr dt there. And then I'm going to derive my circumference formula. Derivative of 2 pi r is going to be 2 pi dr dt. So let's start with what I know. I know my dA dt. So I'm going to start building in that formula. So I know dA dt is negative 409. And I also know that we're looking at a time when the radius is 9 units. So I'm going to divide both sides by all of this. So I'm going to divide both sides by 18 pi. Be careful when you put in your calculator. And I am going to put this one on my calculator just because it's kind of messy. But you do need to use parentheses. I can't pull up my calculator right now, unfortunately, because my Chromebook is being fixed. So this one that I'm using doesn't have my calculator feature. So trust that I'm currently typing it into my calculator. You should get a value of around negative 7.233 when I divide that. So it's approximately negative 7.233. I'm going to keep that value in my calculator rather than try to round too soon. But that's my dr dt. So then I'm going to take that and I'm going to put it into this formula. So it's kind of nice that it's already on my screen. So I'm going to do 2 times pi times the dr dt that I just found. So I've already got it on my calculator screen. I'm just going to hit times 2 times pi. I do get a negative value, and that should make sense. If my area is decreasing, then it should make sense that the circumference is also decreasing. So my dc dt, the rate that my circumference is changing, is negative 45.444. Now, units will be provided on the Delta Math program, but I will tell you, since it's circumference, it's going to be meters per second because it's just the distance that's changing. So that is how you do 2 formula-related rates. You will have 2, usually geometric formulas. You're going to derive each of them and then kind of start gradually plugging in and building what I know so that you can eventually get whatever the goal is, whatever you're trying to figure out what's changing, that's what you should find in the end. And that is the end of the chapter.